In this video, I'm going to be running some tests on the solar panel and the battery that I bought last week, and making a few rookie mistakes with that. But enjoy it, see if you can spot the mistakes before I tell you what they are. So, with that being said, my name's John, amateur radio call sign M7CPT, and let's get on with the video. It's been a few days since I did the unpacking, and I've been in touch with the suppliers, and they assure me that they only sell brand new products. Now, the confusion about the actual solar panel not having the protective film appears to be due to the manual. Apparently, the manual they sent me is an old manual, and the previous model did actually have a protective film on the solar panel. That's no longer the case, so the solar panel is correct, which, yeah, I understand that. They have asked me to perform some tests on the battery. Unfortunately, the test equipment that would have been ideal hasn't arrived. So what I'm going to do, I'm going to use their charge controller to do a couple of tests on the battery. Now, the first one, I've not connected the solar panel, as you can see. What I'm going to do is see how long it takes to drain and see if that tallies close to my estimates, and the next stage will be to charge the battery without any load on. That way I can see just how much use I'm actually getting out of it. So let me just read through the manual, connect the battery up, and see if I need to adjust any settings on here. As instructions go, this thing's a little bit awkward with just having the one button to navigate the menus, change all the settings and get it just right, but as it turned out, all I needed to do was set the battery type. Our next task is to plug everything in and actually run the thing and see just what's going on. At the moment, I've got the load switched off. I just need to press this, a quick press, to turn it on, so I can start the timer at the same time. Got a nice little timer up here, so hit start. I don't know if it's picking her up, but the fan's actually just kicked in on the base, so let's plug in the... Oh, that's strange. E04. Pause that. Earth is E04. Okay, this isn't right. According to this, E04, it says it's detecting a short circuit on the output. There is none. The fan has actually kicked in and the thermostat has come on. The second I press the power button on the radio, it switches off and says there's a short circuit there. So I'm going to have to go through this and find out just exactly what's going on, because I know there is no short circuit at all. If a short circuit would have been there, it'd have been showing up as soon as the fan kicked in, not when the power of the radio was switched on. As I know there's no short circuit, I've turned the short circuit detection off. Hopefully that should work okay. Battery's hooked up, so let's start again. Fan's kicked in and the radio's powered. What I'm going to do is start up the FT8. Now I have to use FL rig for the G90. Let's open up the FT8 program. Oh, better continue that countdown. There is some variation on the actual battery level. It keeps varying between 1 and 3 bars. 1 bar, when it drops to 12.1 volts. It's actually when it's transmitting. When it stops transmitting, jump back up to 12.7. So I don't think that's anything to really worry about. Oh, 1 hour gone, and charge controller is still showing between 1 and 3 bars, depending on which mode it's in. 1 bar for when it's transmitting, 3 bars for when it's receiving. 12.7 volts on receive and 12.1 volts on transmit. Oh, an hour and a half and still going strong. Right, time out. 1 hour, 46 minutes. Strange that the battery's still showing full voltage. I don't know what caused that to occur. It's still showing 12.8 volts and 4 bars. And something must have caused it to drop below the minimum voltage that the charger allows. However, there is still power in the battery. It should actually still be on, so what I'm going to do is tell it to switch back on. And continue the timer. I do not know what occurred then to make it switch off. Had to be the voltage from the chargers or reaching the chargers that dropped, but I don't know what caused it. Let's see how much longer it can keep going. Okay, I found what caused the disconnect. The low voltage reconnect is set at 12 volts. So if low voltage disconnect happens, low voltage disconnect should be set at 10.7 volts. So something caused it to drop below the 10.7 volts. And should be nowhere near that just yet. According to the leaflet on the battery has an internal discharge cut off at 10 volts. So I may be able to reduce the disconnect power of the charge controller just slightly, but I need to be careful about that. I don't want the battery to be fully discharged. Otherwise it won't have enough power for the solar panels to work properly. I'm now showing 12.5 volts on receive and 12 volts on transmit. At this point, I knew there's something I had to be mistaken about. 3 hours 53 minutes and 6 seconds is way shorter than what my estimates were for this battery. The battery should have lasted, if I was working 20 watts, a full 12 hours at 10 watts, I'm told it should have lasted up to 15. So there was something wrong here, and I wasn't sure what. So the next phase was to get it charged back up. So time to hook up the solar panel. Now this is interesting. Still showing 12.3 volts. The 2 bars, well, it's got 2 bars constant, but the other 2 have switched off, and it says the charge has stopped. So I don't know what's going on here. So I'll leave the timer there and continue investigations. It looks like it's might have got a bit too dark to continue charging at a decent rate, so that might be what it's to do with. Right, last night the solar panel disconnected, even though the sun was still out, but it wasn't bright enough to activate it. So today we've got an extremely bright sun. Let's start the charging. Yeah, it's lit up, so it's charging. Continue the timer. A little bit longer than I expected, but it's just this second stop charging, and I'll come back to it tomorrow. Oh, third day of recording. Unfortunately, the timer, as you can see, is reset, so I'll have to just add that to the timer I actually switched off last night. Let's just get this hooked in. And start the timer. Okay. Once again, it seems as though it's got too dark for the solar charging to work, so stop charging from the solar panel, and the battery's still missing the top wire. So it's not finished yet. Looks like I've got another day of charging. Oh, another day of charging off the solar panel. Plug in the panel. And start the timer. Okay, it's been 4.5 hours today. Unfortunately, it looks like it's about to start raining, but as you can see, it's still in the final stage of charging at 12.9 volts. So I'm going to pull in the solar charger, and considering how long it's taken so far, I'm actually going to give up on the solar charger to charge the battery within a reasonable amount of time. As you saw, I've totaled up the total amount of hours that I've had it on the solar charger. It works out to be 17.5 hours. That was not enough to get the charge back up to full charge, and I'll have to revert to the home base charger for charging from the mains. The solar panel may be enough to run the radio, or at least slow down the drain on the battery sufficiently for a decent amount of transmission time. Right, I've got it up to the mains charger. As you can see, it's only actually 60% fully charged. Still charging on the remainder. The charger has picked it up as a LiFePO4, and showing currently 13.6 volts, saying it's got more to go. The manual sheet for the battery does actually say fully charged it's 14.5 volts. So I'm gonna have to wait until it's fully charged and see where it's at. 14.4 to 14.5, so any second now it should be charged. Well, now this is a self-test. Basically, it's testing the battery to see if it loses any charge over the next 10 minutes. So it thinks it's fully charged. Let's see where it is in 10 minutes time. I'll skip the wait for you. One thing I will say, if you're considering buying one of these mains chargers for your battery, whilst this particular charger is a pretty good one, I will mention it is extremely RF noisy, especially while the fan's going, and may not be quite what you want, especially in your shack. No, there we go. It's completed the charge and it says it's full. Okay, just finished the charging, so the charger was able to work up to 14.5 volts, and that was put into the battery 14.35, which, yeah, that's pretty good. Okay, it's been a couple of days since I charged the battery up to full power, and time to hit it with the test meter again to see where it's up to. Let's see where it's at. $13.52. So it has dropped a little bit, but I don't know if that's normal for LiFePO4 batteries. If you have any experience of such a power loss, please let me know in the comments. If it's normal, it's all good. If it's not normal, I need to bring it up with the suppliers again. As I said in the description, I did make some mistakes with this battery. Number one, when I checked the battery immediately after unpacking, I measured 13.6 volts and assumed it had a full charge. 13.6 volts. It does have a full charge. It didn't. Second of all, I plugged the radio into the charge controller instead of going direct to the battery. If I had done this, the radio would have worked for a good 12 to 15 hours without any problems, so it would have been perfectly good. In addition to this, I'm filming this in British winter. The days are extremely short and the majority of days are very overcast, so it's hard to get a good amount of power coming from a solar panel. Certainly nowhere near the capacity of the solar panel. After 5 days of attempting to charge it using the solar panel only, I gave up and used the mains charger for a further couple of hours. If I'd have just been using the solar panel during the short days that I had, it would have taken a full week to recharge the battery from being completely flat. So if you're doing things like winter field days, you may want to bear that in mind. The days are shorter and more likely to be overcast, so your solar panel isn't going to work as efficiently. Over the next week, I'm going to be ordering some parts and building up a power box, possibly even a go box. All depends on how much space I've got in the box I can find and how easy the box is to carry around. 30 amp hours, as you would expect, is quite heavy, so you don't really want to carry it too much. Certainly not up mountains, so I won't be taking this particular battery doing SOTA. However, I may take it into occasional field days and possibly even some parks on the air as well. It all depends on how well I can get a go box sorted. I'll place links down below in the description for the solar panel. The battery came with it and also the charge controller, so if you decide you want to buy them from the same supplier I did, you can feel free to do so. I'll also place a link to the mains charge controller that I bought. However, the solar panels, for some reason, the supplier has upped the price by an extra £30, and the charger for the mains, as I said in the video, is extremely RF noisy, so you may not want to use it anywhere near your shack. One thing I almost forgot, the supplier that I obtained the battery from, because of the scratches that were on the battery, did offer a £20 refund basically for my trouble, and didn't think there'd be any problems with the battery. So it brought the price that I'd actually paid for it down a little bit more, which is always good. Provided that the discharge I noticed after a couple of days is normal for this battery, that is. Don't forget to hit the like and the subscribe and all that usual YouTube stuff. And with that being said, I'll catch you on the air.